In this video, we are going to learn about factors and multiple, the last part, that is how to find HCF and how to find LCM and some properties of HCF and LCM. Now let's get inside the topic. So first you must know what is HCF. HCF is called as highest common factor. So according to the name, first we need to find the factors for the given number. Then from that we need to select the common factors. Then from the common factors we'll select the highest common factor. So that's why we call it as HCF. So there are two methods to find HCF. One is prime factorization method and another one is division method. First we'll see how to solve using prime factorization method. So this method is nearly same to L division method. For example, if I want to find HCF for 28 and 84, okay, so my question is find HCF for 28 and 84. So first step I'll do L division, that is prime factorization for 28 and 84. So when I say prime factorization, what does it mean? Your divisor should be prime numbers. Your divisor should be only prime number. For example, take 28. Now 28 is divisible by 2 table, obviously, because it is an even number. Okay, then what are the other table it has been divisible? Can anyone say? Yeah, 4 table. Okay, 4 table also is possible. Well done. So like that we have different tables. Okay, but if you see, 4 is not a prime number, which means that I am not allowed to take that. Okay, so I can go for 2 table. So 14 2s are 28, right? Again 14 can be divisible by 2 table as well as 7. So but I'll go for 2. Okay, since 2 and 7 both are prime numbers, but I'll go for 2. So 7 2s are 14 and 7 1s are 7. So my divisor or the factors here is 2 into 2 into 7. Now I'll go for 84. So when I do prime factorization, 84 is the even number, so I'll go for 2 table. Now 42 2s are 84. How? First I have 8. So how many 2s are 8? 4 2s are, right? So I have written 4 there. So you can see here I have written 4. So first I have written 4. 4 2s are 8. Then what number I have? 4. How many 2s are 4? 2 2s are 4. So I have written 42. Clear? Now 42 is again what? Even number. So I can go for what table? 2 table. How many times 4? 2 2s are 4. 2 1s are 2. Right? Fine. So now 21 is not possible in 2 table. So check whether it is possible in 3 table. So 2 plus 1, what I'll get? 3. Now 3 is a multiple of 3, right? 3 1s are 3. So which means what? 21 is divisible by 3 table. How many times? 7 times. So 3 7s are 21. Right? Now what I have? 7. So how many 7s are 7? 7 times. 7 1s are 7. Right? Fine. So what is my factors I have here? 2 into 2 into 3 into 7 or 7 into 3. Both are common. Right? So now we have found the factors. What is the next step? I need to find the common factor. So if you see, I have circled the common factor. When you see common factor, you have to see common factors between 28 and 84, not among 28. Okay, you have to see top and bottom, not sideways. You have to see top and bottom. Okay, so when I see, I have 2 in common, another 2 in common and 7 in common. Right? I don't have 3 in common because I have 3 only in 84, not in 28. So I won't take 3 there. Okay, so you have to take only the common factor. Now take the common factor. So what is that? 2 into 2 into 7. Multiply the common factor. So what you'll get? You'll get your answer 28. That is my HCF. Clear? So this is how we solve in prime factorization method. Okay, in your previous classes you would have learned about writing the factors, and from that you take common factor, and from that you take the highest one. That you have learned in your previous class, right? So here, since we are doing prime factorization, first we write the factors, we divide. Okay, then we write the factors, because all these factors are important to get that number. 2 into 2 into 7, then only I'll get 28. Okay, so that's why we are writing it in multiplication form. Then we find the common factor. Since it is multiplication, I have to multiply and write. So my answer is 28. So this is my HCF for the given two numbers, 28 and 84. So the highest common factor is 28. So this is my answer. Have you understood now? Yes. Now we'll go for the next one. So what is the next method? The next method is HCF by division. So that one is prime factorization. Now we are going to divide. For example, if you want to find HCF for 12 and 18. Okay, so first step you have to divide. How you have to divide? You have to divide bigger number by a smaller number. So which one is bigger here? 18. So I will write 18 as a dividend and 12 as divisor outside. Now in 12 table 18 is not possible, right? So I'll go 12 ones because 12 2 is 24, which is greater than 18 and not allowed to write. So I'll go 12 into 1 times. So 12 ones are how much? 12 ones are 12. So you can see I have written here 12 ones are 12. So when I subtract, what I'll get my balance 6. Now since I have a remainder, so what you should do, now you have to divide the divisor by the remainder. So what is the divisor I have here? I have my divisor is 12. So I will write 12 inside and write it as dividend, and I will take this remainder as divisor. Have you understood now? So first step, take the bigger number and write as dividend, and the smaller number outside you divide. Okay, now if you get a remainder, you should keep on dividing again. Okay, so again you have to divide. So which number now you will take? You will take divisor. You will take this divisor and you will write it here inside as a dividend, and your remainder will become as a divisor. Now how many 6 are 12? 2 times, right? So 6 into 2s are 12. When I subtract, what I'm getting my answer as 0. So when you get your answer as 0, which means that you have to stop. Okay, suppose if you're not going to get answer, suppose if you're going to get some other number, which means what? Again you have to take this divisor and you have to divide. Okay, now here I have 0, so no problem. Suppose if you don't get 0, so you should go for the next step of division. So your remainder will become divisor, and the divisor, the 6 will become as a dividend, and you will divide again till you get your answer as that is your remainder as 0. So since I got my remainder as 0, so for which divisor I got remainder as 0? For the divisor 6, which means that the HCF for 12 and 18 is 6. Have you understood? So this is one of the easiest method, and this division method you can use for numbers with for a bigger number. For example, if you're going to find HCF for 384 and 196. So for this prime factorization method is not easy. It will be very difficult. So for those type of sum, you can use this division method. So always remember, you have to divide till you get your remainder as 0. Okay, fine. So now let's get inside the next one. We are going to see the next topic is LCM, that is least common multiple. Okay, so according to the word, that means what? For a given number, you need to find the multiple, and in that multiple find the common, and in that common take the least common one. Okay, so this is called LCM, which you have learnt in your previous classes. So in this class we are going to see how to find LCM by prime factorization method. Okay, for example, if you have a sum like find LCM for 20, 25 and 30. Okay, so using prime factorization method, how to solve? Okay, so that is what we are going to see. Okay, that is by common method, by common division, how I'm going to solve. Okay, so that's what we are going to see. So I'm going to take 20, 25, 30 in common. Okay, I'll take all the 3 in common, because first I'm going to teach you how to find this method in common. You have learnt separately, like 20 separately factorize, 25 separately you just factorize, 30 separately factorize and find the common one, and then you can write the answer. That is also well and good, but this method will be very easy. Okay, if you're going to take all the 3 numbers in common. Okay, so 20, 25, 30, all the numbers I'm going to take common. I'm going to do the L division method. Okay, so what I'm going to do, first see, I have 20, 25 and 30. So in that 20 and 30 are even numbers, right? Which means what? I can go for 2 table, or else even you can go for 5 table also. Either way it is possible. Clear? So but I'll go for 2 table now. How many 2s are 20? 10 2s are 20. So I'll write 10 down and 25. Now 25 is not possible in 2 table, right? So just leave as it is, write 25 as it is, just don't divide. Clear? Now go for 30. How many 2s are 30? 15 2s are 30. So write 15 there. Clear? So always remember, in HCF this is not allowed. In HCF, whatever factor you take, it should divide all the number. That's what HCF is about. But in LCM it's not like that. Okay, you are going to take a number, and if the number divides only one number, the remaining 2, for example 25 is not divide by 2 table, which means what, just write 25 as it is, no problem in that. Clear? Now again 10, 25 and 15, I'll go for 2 table again. So how many 2s are 10? 5 2s are 10, so I'll written 5 here. Now 25 will remain as it is. 15 is also not possible in 2 tables, so 15 also will remain as it is. Now what table I can go? I can go for 3 table or 5 table. So first I'll finish it off with 3 table. So I'll take 3 as my factor. So 5 is not possible, so I'll write 5 as it is. 25 is also not possible, so 25 is also written as it is. Now go for 15. How many 3s are 15? 5 3s are 15, so I have written 5 here. Clear? Now 5, 25, 15, all things are possible in 5 table. The only factor is 5 table. Okay, so I'll go for 5. So 5 1s are 5, 5 5s are 25, 5 1s are 5. Okay, so you have to stop till you get all the 3 numbers as 1. Okay, I have got only 2 ones. I need this 5 to be solved. So again I'll take 5 table. So 1 will remain as it is. 1 5s are 5, 1 1 will remain as it is. Clear? So what is my answer? 2 into 2 into 3 into 5 into 5. Okay, so this is my LCM. Why I stopped here? Because my last, and I had 3 numbers. Now all the 3 numbers has become 1. So which means what? I can stop here. Okay, so once you stop, just multiply the divisor, okay, or the factors which is given this side. Just multiply the factors. So what is the factors I have? So when I multiply 2 into 2 into 3 into 5 into 5, what I'll get? I'll get 300. So my answer for LCM for 20, 25, 30 is 300, which means that the least common multiple for these 3 number is 300. So 300 is the least common. So before 300 I don't have any common multiple. 300 the starting is the first common multiple for these 3 numbers. Clear everyone? So we are using commonly 2 methods. One is prime factorization, the L division method. Okay, in HCF also we use the same L division method but separately, not as a common. And then we used division method, right? So here in LCM we are using the same L division method. Okay, we don't use division method here. Fine. So that I have given also another sum. So for example, if you want to find LCM for 48, 72 and 108, the same method. Okay, but always remember you need to be careful with your factor. Your factor should always be a prime number. Once you just finished off the factor, and then you just multiply all the numbers and find the answer. Okay, so only 2 steps. First step, find the factor which divides the given number. Even if one number is divided by the factor, it's enough, no problem in that. Okay, so you keep on dividing till you get 1. Now you can ask, ma'am, here they have stopped with 2 1 3. So what we do? Now you listen. Now 2 and 3 are prime numbers, obviously. So which means what? 2 can be divided only with 2 and 3 can be divided only with 3. Okay, so that's why they have stopped and they asked us to multiply. So that's why I have marked you in red color to show. So what you should do, how you will find the LCM? You just need to multiply 2 into 2 into 3 into 3 into 2 into 2 into 3. Okay, so your answer is 432. Okay, so you just need to multiply all these numbers. Okay, so all these numbers you need to multiply. Now 2 and 3 are prime numbers, so that's why they have stopped. Anyway, 2 1s are 2, only 2 is possible, and for 3 also 3 is only possible, so that's why they have stopped there. Clear? Fine. So always have this in your mind. Okay, so for LCM only one method, that is prime factorization method. No division method for LCM. Only for HCF you have division method. For LCM there is no division method. Have that in your mind. Okay, so for prime factorization you have to use only prime numbers. Okay, this method we have already learnt in your previous classes. So I hope that now through this video it will be very easy for you to now it will be very easy to do the sum. Okay, fine. Now we'll go for the next one. The last one, that is a property. We are going to see one property, that is if I have LCM, HCF and the numbers. Okay, then how I'll find them? Because from the numbers only I'm going to get LCM and HCF and LCM. Okay, so if I have all these 3, so how can I find if one is missing? For example, if HCF is missing but LCM and number is given, how can I find? Or if HCF and LCM is given, number is missing, how can I find? Okay, so for that only we have a formula. So what is the formula? First I'll say the formula for you all. Okay, so the formula is, you can see here, I hope that you're able to see. I'll just highlight and show for you. HCF into LCM is equal to product of numbers. So this is my formula. Okay, so what is the formula which connects all these three? That is HCF into LCM. The product of HCF into LCM is equal to product of numbers. That is the question. Okay, so for example, I have a sum. If HCF is 16 and the product of two numbers is 3072, find the LCM. Okay, I have HCF and the numbers, but I don't have LCM. So how I should solve? So just write the solution. First write what is given. HCF is what? 16. And what is the product? 3072. Now write the formula. What is the formula? HCF into LCM is equal to product of numbers. Okay, now substitute the value. What is HCF? 16. So write there. Do I know LCM? No. So write LCM as it is. Into LCM equals to, what is the product? 3072. Now what I should find? I need to find LCM. So let LCM remain as it is. Bring this 16 to the opposite side. So in multiplication, when it comes to the opposite side of the equal to, it will become what? Division. Okay, so 3072 by 16. So you can do the normal division. When you do the normal division, what you'll get? My answer is 192. So LCM of the given number is 192. Clear? So this is how you solve the problem. For example, if you have another number, for example, I have another question. The LCM of two number is 2079 and the HCF is 27. If one number is 189, find the other number. Okay, so what is the formula? HCF into LCM is equal to product of two numbers. So one number into another number. Now I need to find another number, right? So what I should do? I have two numbers. Okay, so one number only I know, another number I don't know. So what I should do? Yes, first multiply HCF into LCM, then divide by the first number. You will get the answer. Okay, according to the formula, HCF into LCM is equal to product of two number. First multiply HCF and LCM. Then in product of number, I have only one number. I don't have another number. Right? So to find another number, what I will do? I'll bring that one number to the opposite side. So it will become what? Division. Okay, so LCM into HCF by first number. So substitute the value. What is the value? 2079 LCM into HCF is 27 by 189. So first multiply. 2000. First you need to do what? First you need to multiply 2079 into 27, like normal multiplication. So what you will get? You will get 56,133. Then you divide this number by 189. Okay, so when you divide, what you will get? You will get your answer as 297. Clear? So this is how you have to solve the properties for like if you have all the three numbers and you need to find one. So this is the method to solve. So always remember the formula. So what is the formula? HCF into LCM equals to product of numbers. Clear? So I hope that in this video you have understood how to find HCF, how to find LCM, and also I hope that you learned the property. Okay, so always remember HCF we can find by two methods. What are the method? One is prime factorization method. You can factorize separately in L division, then find the common factor and multiply all the common factors. That will be your HCF. Okay, and second method is what? Division method. So divide the bigger number by smaller number. Okay, you keep on dividing till you get your remainder as 0. So for which divisor you get your remainder 0, that is your highest common factor HCF. Okay, then we come for LCM. So LCM, according to the question, you need to find the least common multiple. So here we use only one method, that is prime factorization method. You can do factorization separately, or else you can do like a common one. I have showed you in an example. Okay, so write all the numbers. What are the number given? Take the number in common and find the factor. But always remember you have to use only the prime numbers. So take the prime number and you divide till you get all the number as 1. Okay, then you multiply all the factors. The outside which you have written down, so all the factor you multiply, that will be your answer. Okay, so always remember your LCM, the answer, just have this hint in your mind. Okay, the LCM which you get, okay, the LCM we are getting, no, so that LCM will always be greater than the question. For example, let me get you to the sum. Okay, so you see here, I'll take this question. Okay, so if you see here, I have the question. I have the question over here is LCM is 2079 and the HCF is 27. One number is 189, another number is 297. So did you see clearly? From this I'll say you the hint. If you see LCM, what is my LCM? My LCM is 2079 and the LCM is greater than both the number. The LCM is greater than 189 as well as the LCM is greater than 297. So did you see? So always remember your LCM will be always greater. Okay, and if you see a HCF, and HCF will be always lesser than the question. Okay, so if you have a number, okay, any number, your HCF will be always lesser. Okay, so this is one hint to remember whether your sum is right or wrong. Clear? Fine. So I hope that this video helped you to understand in depth about HCF and LCM. We'll meet you all in the next video. Thank you everyone.